Now, let's come to the very basics of the flows. In a volume control ventilation, where the volume is what is driven to the patient, the flow pattern is basically a square flow pattern. And the reason it's a square flow pattern is you need to deliver this certain volume. So you need to increase or ramp up the flow till the volume is being delivered. Once the flow reaches your set flow rate, it holds till the volume gets delivered. Once the volume gets delivered, then the flow drops off and then the volume also is exhaled from the patient. Whereas in a pressure control ventilation, the flow pattern is normally a decelerating flow pattern. But there are some modes which are dual modes. And we will talk about it in the webinar that we are organizing in the future, where we talk about the advanced modes of ventilation, where modes like your PRVC, pressure regulated volume constant, or VTPC will also get discussed. Let's go forward to the first primary mode, which is the VCV, or the volume control ventilation. By definition, a volume control ventilation is where the clinician sets the tidal volume. The flow is set by the physician in some machines, or the I time is set by the physician in some machines, and the I time then decides the flow. The flow delivery is constant, does not vary according to the patient demand. In some machines, as I said, the tidal volume and the peak flow is set. In some machines, the tidal volume and the inspiratory time is set. Based on the condition of the lung, the compliance and the resistance, the pressure can vary. In a pure volume control ventilation, the flow delivery is square. In a mixed mode ventilation, the flow delivery can be decelerating. Let's go forward to how the flow and the pressure versus time waveforms look in a volume control ventilation. You can see in a volume control ventilation that if the patient's compliance is going down or if the resistance is increasing, you can see that the third waveform, the pressure has gone above what it was in the earlier two when the compliance and resistance were constant. So the volume is constant, pressure is completely now dependent upon the patient's compliance and resistance. I would halt here because I believe Dr. Bala wants us to do a second poll. So, Dr. Bala?
Yeah, the poll is there on the screen. Do you think different nomenclature in ventilator modes by different manufacturers leading to confusion and putting the patient at risk? Please answer yes or no. Oh, it's almost 90% said yes.
I would take it as a feedback as a person from a company that makes ventilators and has a large presence. And I'm completely echoing what all of you said. Each of us has their own nomenclature for exactly the same thing. And that sometimes confuses a clinician. Now, as I said, the pressure in a volume control ventilation changes according to the compliance and resistance of the lung. But you can see that the tidal volume and the peak flow remain constant. Let's go forward to the next mode, the pressure control ventilation. Again, by definition, a pressure control ventilation is where a clinician sets an inspiratory pressure and an inspiratory time. Based on the patient demand, the flow will vary. The tidal volume will vary according to the compliance and resistance. And always the flow delivery is a decelerating flow. So here what the equipment does is continues to flow to actually generate a flow till the pressure that the clinician sets is being reached. And at that point of time, it continues to hold that till the inspiratory time is met and then drops the flow down. If you look at it from the graph, you can see here that the pressure waveform stays constant, the I time stays constant, but based on the compliance or the resistance, the peak inspiratory flow and the tidal volume would actually change. So the key difference between a volume control and a pressure control, the one constant is one of the parameters, either volume or pressure, would get impacted by the resistance and the compliance of the lung. In a volume control resistance, in a volume control of ventilation, the pressures vary. In a pressure control ventilation, the volumes vary. Now, if you look at both PCV and VCV, all the modes of ventilation, assist, SIMV, can be used either as a PCV breath or a VCV breath. In an assist control, all the breaths are actually time cycled and or pressure limited. In an SIMV breath, the machine initiated breaths are time cycled and pressure limited. The spontaneous breaths can either be pressure supported if they are in the what we say the inspiratory window. If it is not, then it has to be the patient's own. Now, indications of a PCV. Now, if you want an enhanced patient ventilator synchrony, because the patient is able to determine the flow according to the resistance of the lung or the compliance of the lung, there is more patient ventilator synchrony in a pressure control ventilation. That is why most of the time when the compliance of the lung is not so good, pressure control ventilation is a preferred mode of ventilation. But finally, whether volume or pressure, the decision is the clinician and the pathology that the patient is presented with. Many a times, many clinicians feel that pressure control ventilation, because of its lung protectiveness, the lower inspiratory pressure with a decelerating flow can actually improve the VQ matching. And if you want to improve the oxygenation, keeping the pressure constant, you can always increase the I time, which then increases the mean airway pressure and helps in improving oxygenation. So most of the times, whenever lung protective strategy is required, people prefer to go in for a pressure control ventilation. Now, I would not go into this because we've already looked at this, the difference between volume and pressure control ventilation. I would not want to repeat myself.